Today, we're going undercover. We're diving deep into the world of software development, but we're not writing the code, we're hunting for what's broken. We're basically becoming bug detectives. So grab your magnifying glass, because our investigation starts right now.
You know the feeling, right? You're in the middle of typing something, you tap a button, and poof, the app just disappears. Or maybe a feature just flat out doesn't work. We have all been there. And that moment of frustration, that is the exact crime scene our detectives are trying to prevent.
So what is this whole investigation officially called? Well, it's software testing. Think of it as the formal process of dusting for fingerprints and examining all the evidence, which is the software itself, to find those pesky defects before they ever make it to you, the user. The whole point is to make sure the program does exactly what it's supposed to do. All right, so let's start our investigation with the absolute fundamentals. What are we really looking for when we put software under the microscope? Every good detective has a method, right? A way of thinking. And in the world of bug hunting, there are two main ways to approach a case. So think of it like this. On one side, you've got manual testing. This is your classic boots-on-the-ground detective work. A real person is clicking around, exploring the software, using their intuition to spot weird stuff a machine might miss, like if a button is just in a really awkward place. Then you've got the forensics team, automated testing. They use special tools and scripts to run thousands of checks automatically. This is amazing for stuff like regression testing, which is just a fancy way of making sure a new update didn't accidentally break an old feature. You know, a big investigation isn't just one single event. It happens in stages. You don't just walk onto the crime scene and instantly solve the case. You have to start small, with individual clues, and build your way up to the full story. Let's see how that case gets built, level by level. And this lays it out perfectly. First up, step 1, unit testing. We're looking at the tiniest pieces of evidence in isolation, like a single function in the code. Once those check out, we move to integration testing. This is where we see how all those individual clues connect and work together. Then we get to the big picture with system testing. We're looking at the entire, fully assembled piece of software. And finally, acceptance testing. This is where we go to the client, the end user, and confirm that the software actually solves their problem. Case closed. Now, the best detectives don't just search randomly. No way. They use clever techniques to work smarter, not harder, and find those really well-hidden bugs. This brings us to a couple of classic techniques. First is black box testing. Imagine the software is a locked box. The detective has no idea what's going on inside. They just test inputs and outputs like a normal user would. You know, if I click this button, does the right thing happen? On the flip side, you have white box testing. Now, the detective has the full blueprint. They can see all the internal code and can check every single wire and pathway to make sure the logic is solid from the inside out. So how do you keep an investigation this complex organized? You use a test case. This is basically the official case file. It's a document that lays out the exact step-by-step instructions to follow, the data to use, and, this is the most important part, the expected result. It turns a simple hunch into a verifiable, repeatable test. And here's a perfect example of one in the wild. This test case, called TC_login_001, is all about making sure the login works. You can see the steps are super clear. Go to the login page, type in a valid username and password, click the login button, and the expected result? The user successfully logs in and gets taken to their dashboard. If that doesn't happen, bingo, we've found a bug. But look, a smart detective can't possibly test every single possibility. That would take forever. So they use clever tricks. And one of the best is called boundary value analysis. The whole idea is that bugs just love to hide out at the edges of an input field, the minimum and maximum values. This image shows exactly how it works. Let's say a field accepts a number between 0 and 100. Instead of testing every single number, you just test the boundaries, 0 and 100. And then you test what's right next to them, like -1, 1, 99, and 101. It's a surprisingly simple but super efficient way to catch a ton of common errors. So after all this detective work, you might be wondering, why does it matter so much? Why can't developers just, ship the code and hope for the best? Well, it all comes down to building trust. First off, it's about quality assurance. It's what ensures the product you're using is reliable and actually works. It's also about cost efficiency. Trust me, finding a bug early in the process is way, way cheaper than fixing it after it's already out in the wild. Then there's risk mitigation. This prevents massive failures that could wreck a company's reputation. But most importantly, it all adds up to user satisfaction. A smooth, bug-free experience is what keeps people happy and coming back. So I'll leave you with this thought to chew on. We've talked about testing as this big hunt for flaws and mistakes, but maybe there's another way to look at it. If this constant search for what's broken is the very thing that stops our digital world from falling apart, then how is this process of breaking things actually essential for building a more reliable and trustworthy world for all of us? Hey, if you enjoyed playing detective with us today, do us a favor and hit that like button, share this with a friend, and be sure to subscribe to Tech Talk 101 for more explainers just like this one. Thanks for watching.